Good morning, everyone. So today we are solving the problems related to air standard cycles. So before going point of view, we have to check the relations, that is thermal efficiency relation, main effective pressure relations of Otto cycle, DC cycle and dual cycle. So here in this table we have listed the formulas of thermal efficiency, mean effective pressure of three different cycles. So you should remember these formulas. Along with these formulas you should know the relationship between pressure and volume, pressure and temperature, and volume and temperature. If you know these many formulas, then it will be very easy for you to solve the problems related to air standard cycles. Now let us start the first problem of the air standard cycle. So what it states: an engine working on ideal Otto cycle. So cycle given over here, it is Otto cycle, as the swept volume, that is nothing but Vs. Vs is nothing but 0.12 meter cube, and clearance volume, that is nothing but Vc. Vc they are given 0.03 meter cube. And next sentence what I am given: the pressure and temperature at the beginning of the compression. So if you remember the PV diagram of the Otto cycle, beginning of the compression means the state point 1. So P1 they are given 1 bar and T1 they are given 100 degrees centigrade. So 1 to 2 it represents compression, and next they are given if the pressure at the end of constant volume heat addition. So heat addition is process is nothing but 2 to 3. So pressure at the end of constant volume heat addition means the point 3, that is state point 3, that is nothing but, since they are given pressure, so this should be P3. P3 they are given 25 bar. Then after this we need to find out, calculate air standard efficiency, temperature and pressure at all salient points of the cycle. So you need to find out efficiency and temperature and pressure at each point of the cycle. We have to draw the PV diagram of the Otto cycles. It is also known as constant volume cycle because heat addition is given with respect to constant volume process, hence it is known as constant volume cycle. So 1 to 2 is the compression, 2 to 3 is your heat addition process, 3 to 4 is the expansion, and 4 to 1 is the heat rejection process. These two processes are isentropic, these two processes are constant volume process. So first you need to draw the PV diagram of the given cycle. Here it is Otto cycle, so we have to draw the Otto cycle PV diagram. Next we need to find out the given data. So we have to write given data: stroke volume Vs, clearance volume P1, T1 and P3. Once you write the given data, next we need to find out, for efficiency we need to find out the, what you need to find out, that is the compression ratio. Compression ratio is nothing but V1 by V2. So how to find out V2? V2 is already given, that is nothing but clearance volume, that is nothing but V2 and V3 are equals, so that is nothing but your clearance volume. So clearance volume you know, so V2 you know. So next we need to find out V1. How to find out V1? Vc plus Vs, that represent V1. So add these two terms, you will get the value of V1. Once you got the value of V1, directly we need to find out the compression ratio, RV, V1 by V2. So 5 is the answer for compression ratio. Once you got the value of compression ratio, just substitute in the efficiency equation. So this is the efficiency formula for Otto cycles. Just you need to find out the efficiency, so just substitute back and get the value of efficiency. Once you got the efficiency, one question is over. Next we need to find out temperature and the pressure, also input P1, T1 you know. Next we need to find out P2, T2, P3, T3, P4, T4. So these many things you need to find out. So first go through the process 1 to 2. Use the relation, that is T2 by T1 is nothing but RV, that is V1 by V2 to the power gamma minus 1. So just substitute whatever the T1 is you know, RV you know, gamma is 1.4 for air. So just substitute and get the value of T2. Similarly, use the relation for pressure. P2 is nothing but P1 times RV to the power gamma. So just substitute and get the value of P2. So you are finding out pressure and temperature at salient point. It is just nothing but replication of your derivation. So you should remember the derivation of Otto cycle, DC cycle as well as dual fuel cycle. If you remember that derivation, then it will be very easy to find out the pressure and temperature at all the points. So next process is 2 to 3. It is the constant volume process. So volume will get cancelled. So you will get to know P2 by T2 is nothing but P3 by T3. So P2 value you know, T2 you know, T3 you know. So just P3 you know. So just use this relation and get the value of T3 in terms of Kelvin. Remember temperature you should substitute in Kelvin. So you will get temperature like this T3. So T3 P3 over. Now remaining is T4 T4. So again 3 to 4 relation you have to remember. So using this relation you get the value of T4. T3 you know, just you get the value of T4. Next again pressure and volume relation, get the value of P4. So in this way you are going to find out the pressure and temperature at all salient point. You remember pressure, temperature, T1 will be minimum in the Otto cycle, T3 will be maximum. So T2 lies between T3 and T1 and T4 lies between T3 and T1. Just you remember this concept and you just cross verify your answer by roughly. So on to the second problem. So in constant volume cycle, so here they are given constant volume cycle, so that is nothing but Otto cycle only. So Otto cycle, another name it is given as constant volume cycle because heat addition takes place at constant volume process. Similarly for DC cycle it is known as constant pressure process because heat addition takes place at constant pressure. Whereas dual fuel cycle it is known as limited pressure cycle. So since it carries two processes, volume and pressure, heat addition and pressure will be limited. So hence it is called as limited pressure cycle. So you should remember Otto cycle also known as constant volume cycle, DC cycle also known as constant pressure cycle, and dual fuel is known as limited pressure cycle. So constant volume cycle, the pressure at the end of compression, that is nothing but P2 is equal to 15 times that of at the start. So P2 is equal to 15 times P1 or P2 by P1 is nothing but 15. And temperature of the air at the beginning of the compression, that means T1, they are given 37 degrees centigrade, converted into Kelvin, and maximum temperature, so just now I told maximum temperature will be at point 3. So T3 they are given 1950 degrees centigrade, so that is nothing but converted into Kelvin. T3, find compression ratio, thermal efficiency of the cycle, heat supply per kg of air, that is M, they are given 1 kg, work done per kg of air. Note on the PV diagram. Next, note on the given data. So P2 by P1 15, T1 they are given, converted into Kelvin, T3 also they are given, converted into Kelvin. Next, use the relation pressure and volume. So we know that P2 by P1 also nothing but V1 by V to the power gamma, or compression RV to the power gamma. P2 by P1 you know, use this relation, get the value of RV. RV will get 6.9. Once you got the value of RV, directly substitute in efficiency, you get the efficiency, that is 54%. One question is over, compression ratio is over, efficiency is over. Next we need to find out the temperature at 2. Once you got the value of temperature at 2, use the relation once again, T2 equal T1 into RV to the power gamma minus 1. So use the relation and get the value of T2. Once you got the value of T2, maximum temperature is given. So heat supplied is nothing but MCV, because here E supplied is given for the process 2 to 3. So M into CV, a constant volume, CV into T3 minus T2. So E supplied is nothing but M into CV into T3 minus T2. So here M is taken as 1 because they have asked heat supplied per kg of air. So M is 1. CV, you know, CV value for A is nothing but 0.72. T3 they are given in the question itself. T2 you have found out. So just substitute, you will get E supplied per kg of air. Next, after heat supplied, you have to need to find out work done. Work done, now you have to find out. One easy method is efficiency formula. Efficiency is nothing but work done divided by heat supply. So heat supplied, you know, efficiency, you know, just in that relation you need to find out the work done. So work done will be efficiency multiplied by heat supply. So just do that one and get the value of work done. So this is very simple problem. Next we will move on to the next problem. Third problem, what they are told, the compression ratio directly given, it is 8 of Otto cycle it is 8. RV value they are given at the beginning of compression process. Pressure is 1 bar and temperature is 300 Kelvin. That means P1 is 1 bar, T1 is 300 Kelvin. Next, the heat transfer to the air, that means heat supply per cycle they are given, it is 1900 kilojoule per kg of air. So heat transfer is for the process 2 to 3, value of Q they are given. Calculate pressure and temperature at all salient points and mean effective pressure. The PV diagram. Once you note on the PV diagram, note on the given data. That is pressure they are given, temperature RV they are given. Now we have to find out temperature and pressure at salient point. T2, use the relation, same relation. T2 is nothing but T1 times RV to the power gamma. Just substitute and get the value of T2. Similarly, get the value of P2. Once you got the value of T2 and P2, next you need to find out T3. For T3, they are given heat supply for the process 2 to 3 is 1000 something value they are given in the question. So heat added is nothing but MCV T3 minus T2. So here M they are given per kg of air, so 1 kg. CV of air, you know, heat added they are given, T2 value you know. So substitute and get the value of T3. 1900.72 T3 minus T3 you will get like this. Once you got T3, next you need to find out value of P3. So P3 it is a constant volume process, so volume will get cancelled. P2 by T2 is nothing but P3 by T3. Here our only unknown term is P3, rest all terms you know, substitute and get the value of P3. Once you got the P3, next only remaining point is 4. 4 we need to find out. So use the relations, same relation what you have used in earlier case, same thing. We find out T4. Once you got the value of T4, next you move on to the P4. So P4, T4. So all the pressure and temperatures you got the answer. Next one more is you need to find out the mean effective pressure. For mean effective pressure, one term is there in the formula, that is beta. Beta is nothing but your pressure ratio. So pressure ratio it is given by P3 by P2. So you need to find out this pressure ratio or explosion ratio. So use this formula and get the value of beta. Once you got the value of beta, next mean effective pressure formula is that. Substitute everything, gamma you know, RV you know, P1 you know, beta you know. So substitute everything and get the value of mean effective pressure. So calculation, do it properly, don't do any kind of mistakes so while doing the calculation. So this is the 3 problems related to Otto cycle. Next we will move on to the problems related to diesel cycle. So what states, an engine with 200 mm cylinder diameter. So cylinder diameter they are given 200 mm and stroke length they are given 300 mm. So D and L they are given. So why they are given this one? To find out the swept volume. Swept volume is nothing but pi by 4 d square into L. D you know, L you know. So you can find out swept volume. Works on a theoretical diesel cycle. So the cycle is over here, it is diesel cycle. So in the question, first thing what you have to do, which cycle they are given, auto cycle, diesel cycle or dual cycle. So you have to identify the cycle first, then you need to draw the PV diagram, then you need to write the given data. So this is cycle PV diagram you have to draw. Next, they are given initial pressure and temperature of the air is 1 bar and 27 degrees centigrade. So initial pressure and temperature, that means P1 and T1. So T1 they are given in terms of degree centigrade, convert it into Kelvin. Next, they are given the cutoff is at 8% of the stroke. Remember this word, the cutoff is at 8% of the stroke. They are given cutoff 8% of the stroke. This I will explain during the problem. Next, compression ratio directly given RV 15. Determine pressure and temperature at all sealing point. Theoretical extended efficiency, mean effective pressure. Power developed if there are 400 working strokes per minute. So remember this sentence also. During the problem I will explain this one. Power developed if there are 400 working strokes per minute. PV diagram of DC cycle. So 1 to 2 compression, 2 to 3 heat addition at constant pressure, 3 to 4 expansion, 4 to 1 heat rejection. So note down the given data: diameter, length, P1, T1 and the compression ratio. So swept volume has already told pi by 4 d square into L. Substitute d and L in terms of meter. Here they are given mm, just convert it into meter and get the value of Vs. Once you got the value of Vs, next we have to find out the V2, that is clearance volume. Clearance volume also is nothing but V2. So RV formula you know, V1 by V2, that is nothing but V1 is nothing but clearance volume plus stroke volume, swept volume, yes, divided by Vc. So Vc is nothing but V2, so 1 plus Vs by Vc. So now just substitute, instead of Vc just substitute V2. So RV you know, Vs you know, only unknown term is V2. So you will get the value of V2 like this. So once you got the value of V2, in the sentence, in the problem they are given, that is cutoff takes place at 8% of the stroke. So they are not given cutoff ratio in pressure ratio is there in the auto cycle. Pressure ratio is nothing but, since it is a constant volume process, pressure ratio is nothing but P3 by P2. Similarly, cutoff ratio is nothing but V3 by V2. But here in this case, they are given cutoff take place at 8%. They have not mentioned anything about ratio. So hence, the meaning of this one is cutoff means V3 minus V2, that is equals 8% of Vs. So how we can write this one? V3 minus V2 is equal to 8 by 100, because 8% into Vs. So in this equation only Vs, V3 is unknown, V2 you know, Vs you know, substitute and get the value of V3. So remember, just read the sentence carefully. Cutoff means V3 minus V2. Cutoff ratio means V3 divided by V2. So just make a note of this one, and from this equation get the value of V3. So once you got the value of V3, next find out the cutoff ratio. Cutoff ratio is nothing but V3 by V2 denoted by alpha. So alpha you will get 2.12. So cutoff ratio is over, RV is over, efficiency equation you have to remember. Once you remember this efficiency equation, substitute everything, you will get the efficiency formula. So after efficiency, you need to find out the mean effective pressure. Cutoff ratio already you have found out. P1 you know, RV you know, gamma you know. So substitute and get the PM in terms of bar. So once you got the mean effective pressure, next they have asked to find the power developed. As I told during the problem, remember that sentence, power developed if there will be 400 strokes per minute. if there are 400 working strokes are there per minute, what is the power developed by the engine? So before power developed, you need to find out the work done per cycle. So how to find out work done per cycle? As per the definition of mean effective pressure. What is the definition of mean effective pressure? It is nothing but net work done per cycle divided by stroke volume or swept volume. So PM value you know, stroke volume you know, that is nothing but Vs. So using this equation, find out the work done per cycle. So work done per cycle, you will come to know. Once you got the work done per cycle, this one multiply by number of cycle per second, it will give the power developed. So there are 400 working strokes, that means per minute. So you have to convert how many working strokes are there per second. So whatever work done you got, just multiply by that 400 divided by 60. So you will get power developed by the engine. So 6.98 multiplied by 400 divided by 60. This is conversion from minute to second. So you will get the power developed by the engine. That is nothing but 46.53. So just remember how to get the power work done into number of cycle if the working strokes are given. Next, the only remaining thing is pressure and temperature at salient points. So next find out T2. Similar way you need to find out T2, P2, T3, P3, T4, P4. T2 just find out in terms of Kelvin only you have to find out. Next P2 similar way you will get 18.38 bar. Next P3 also equal P2 since it is a constant volume process. So alpha you know cutoff ratio. So from the cutoff ratio also you can get RL, so you can use that P3 V3 by T3 is equal to P2 V2 by T2. That equation also you can use, or else you can use this equation also, that is alpha cutoff ratio is nothing but T3 by T2. Any one equation you use to find out the value of T3. So get the value of T3. P3 also the remaining is T4 and P4. So process 3 to 4. Use the relation isentropic. So T4 by T3 is in terms of volume, it is given like this. So remember this one, T4, once you got the value of T4, go for P4. So P4 also you will get like this. So in this way you are going to find out the pressure and temperature at all salient points. So this pressure and temperature salient point, how to find out, is just replication of the work derivations. So derivations are very important. 3 derivation auto cycle, DC cycle and dual cycle. How you have done that derivation, very important thing. So today we have solved 4 problems. So next class also 4 problems, totally 8 or totally 9 problems we will solve in this module, and rest of the problems I will give in the assignment, and some are there in the notes. So refer that one also. Any doubt you can ask with me.